only software developer of a program I've been working on as a hobby called eagleeye. Eagleeye is a image processing software development framework, I guess. I came up with the idea for this in grad school when I was doing a lot of software development in MATLAB, but I needed to actually deploy my software on embedded robotics platforms and the like, where I couldn't always put MATLAB on the platform, or I didn't want to deal with the overhead of MATLAB because it was just too slow. I wanted I wanted a set of tools where I could develop software in C++ easily and as quickly as I could develop in MATLAB, or faster, and then still have all of the speed of a a native C++ implementation, or even using CUDA to accelerate my application. So what I'm going to show you is I'm going to develop a processing pipeline for doing image registration between a set of images stored in a directory and a single reference image. So first things first, I'm going to load the directory. Alright, so this creates a frame grabber, which I can go ahead and just stop for now, which just loads every image in the directory sequentially. And then I'm going to load a source node, which will load a single reference image. I'm going to select that reference image as the first image in the directory. Then I'm going to add a node for registering the reference image to, for registering the source image to the reference image. So I'm going to select the, one second, I need to actually run the reference image. Alright, so that loaded the reference image in this node, and then I set it as an input to this other node over here. Alright, so now I'm going to add a few, I'm going to run it. What that should do is, hold on, what that should do is it should process a bunch, it should process in all the source nodes, or the input nodes, input images, and register them to this reference image. Perhaps it just didn't load correctly. Alright, so looks like that's running correctly. Alright, so as you can see, it outputs three different GPU mat outputs. There's the overlay image, which is the input image overlaid onto the reference image. The input with respect to reference, so it's just the reference image warped, the input image warped to the reference coordinate, or the reference image frame, and then the input mask warped to the reference as well. So let's add some visualization so we can see what this is actually doing. So I'm going to add another node to extract those. Alright, so these two nodes will extract those inputs and put them on the main image channel. Alright, so I'm going to extract the overlay, and I'm going to extract the mask. And then I want some display nodes to display what's on the input channel. Alright, so now I can see the image after it's been aligned to the reference, and then the mask, so you can see what's going on. I'm going to restart the index of the frame grabber, and I'm just going to stop the processing pipeline so we can look at things for a moment. So here we have two images being aligned to each other, and here's the mask of the alignment. Alright, so pretty easy. I can add a few other things like saving the image to disk, stuff like that, but that's the gist of creating a processing pipeline in this application. So now I really want to talk about the most important feature of this is the runtime compiled C++. It's a library that I integrated that allows you to edit the source code of each one of these processing nodes and recompile it and see the results in real time. So I'm going to go back to the registration node I have over here, and I'm going to put a breakpoint. And you can see the breakpoint can be hit because that's the code that's currently loaded. So I'm going to comment this all out. basically disabling this section of code for now, so you can see what happens. So I'm going to hit save and it's going to recompile. You can see that the breakpoint can't be hit because this code hasn't been loaded in the application. But as it recompiles, you can see the output of MSVC compiling and everything. Object swap has been complete, which means the compilation succeeded. I'm going to put a breakpoint in some active code, and look, now we can breakpoint in the new code. We can also run everything, and you can see that nothing's going to happen because I commented out the homography stuff. So you see nothing's actually going on. Alright, so I'm going to stop it again. I'm going to go back and breakpoint it. In this code here, actually, I originally developed this all with runtime compilation. I didn't write, say, perhaps the last half of this function until I wrote the last half of this function in like a runtime compiled manner. So I'm going to save it again. It's recompiling again. Alright, see the runtime compilation completed without any errors. So we can go back here. I'm going to hit start. And we can see the image alignment should be going again. I might have to redefine, yep, I have to redefine the reference images for the inputs. Alright, so I'll restart that, start it, and there we have it. Now is running the code, we'll run the code for registration again. So you can see with this, it's really easy to define processing pipelines. You can see the results of them. You can debug the results of them. There are tons of other features. I have some stuff in here for doing plotting, stuff in here for doing 3D scenes, doing point cloud acquisition. But it's all very experimental. It's really in the alpha stages, and I mean, I'm the only developer on this, and it's my hobby project, so it is what it is. Hopefully some people would like to check this out, maybe get some more users. With some more users I can get some feedback, bug reports, and other people helping work on this. It's an open source project, so any help would be great. There's one other thing I wanted to show. So these processing pipelines can also be saved to an XML or YML format, and then you can just reload them really easily through that. So it supports well, I mean, it's all designed to make the job of a image processing engineer easier, and hopefully it'll do that.